Hello students, this is Mr. Allen here. We're going to look at our next geometry lesson, which is on section 1.3 called measuring segments. So last time we looked at points, lines, and planes and some basic postulates. Today we're going to carry on and we're going to focus specifically on segments. The objective here today is students will be able to find and compare lengths of segments. So the first thing we have is a ruler postulate. And just as a reminder, a postulate is something that is assumed to be true without proof. So we are assuming that this is to be true. And basically what the ruler postulate is telling us is that we have some point A and some point B, for example, on this line, that we can assign the coordinates on a ruler, if you will, to those points. So to just be clear, what it says is every point on the line can be paired with real numbers. So for example, this point B could be paired with some real number B, whatever that might be, depending on if we're doing inches or centimeters or whatever. And there's a one-to-one correspondence. And the real number that corresponds with the point is called the coordinate. So for example, and I don't know what the markings are here specifically, but we might say that, you know, let's just guess here. So let's say that's 3. We'll say that A has the coordinate of 3 and B has the coordinate of 5, 6, 7, 8. If we, let's say that's in centimeters or something like this. Okay, that's what the ruler postulate says. So here's an example of how we might want to use the ruler postulate. So let's say I wanted to know the distance between points A and B. So what I can do is I can pair the coordinates of A and B up like so. So here we can see that the coordinates for A, well, A is at -2 and B is at 2. So if I want to find the length of AB, that would be equal to, and so we're going to use this formula. You may have seen this in Algebra 1, which is the distance formula, length from A to B. Oops, that's an absolute value. So in other words, you got to make it positive, whatever it is. So in this case, A is -2, B is +2. So you get the absolute value of -4, which is 4. The distance is 4. Or if you don't like that, you could literally just say we got to go up 1, 2, 3, 4. It's 4 units long. Now these are the mathematical ways to do this, but that's the distance formula, and we're using the ruler postulate. Okay, the ruler postulate. So the answer there is 4. Segment addition postulate. This is a big one. This one's super important, and basically what it says is the following. So let's say you've got 3 points, A, B, C, and they are collinear, which means they're on the same line. And we know that B is between A and C. So we know that B is somewhere here, not necessarily in the middle. We would say, oh, and I should have mentioned this on the last slide, that the length of AB plus the length of BC is equal to the length of AC. Now, what I forgot to mention on the last slide is AB is equivalent or means the length of segment AB. Okay, so AB without the vertical bar means the length of AB. Okay, so when I talk about AB with this segment symbol, I'm talking about the segment itself. When I talk about AB without the segment symbol, I'm talking about its length. So basically what we're saying here, and I'll just make this very simple, let's pretend that this distance is 2, this distance is 5. So this length is 2, this length is 5. What would be this entire length here from A to C? Well, of course, it's going to be 7, right? Because 2 plus 5 is 7. Okay, but we would write that if we didn't know what those numbers were, we would say that the length of segment AB plus the length of segment BC is equal to the length of segment AC. So let's look at an example here. Here we're given that the length of the segment EG, so this length right here is 59. We want to find EF, and we also want to find the length of FG. Well, we know based on the postulate we just looked at, which is segment addition postulate, that EF plus FG FG is equal to EG. Well, what is EF? Now I'm going to do a substitution here. I'm going to say it's 8x minus 14. So I just plugged that in there for EF. What is FG? Well, FG is this distance. It's 4x plus 1. And what is EG's length? Well, EG's length is 59. So now we've got to do a little bit of algebra, and that's no big deal. We got to take 8x plus 4x, which is 12x. Negative 14 plus 1, I think, is negative 13, which will give us, or equal 59. So now we need to solve this, and I'm just going to review some of this algebra stuff. So I want to plus 13 on both sides, and that's going to give me 12x equals, well, let's see here, that'd be, I think, 72. Now here's a hard question. How do I take 12 into 72? Well, in case you don't know what that answer is, the answer is 6. So x is 6. Now look, we found x. We still have to find EF and FG. Now I am only going to find FG for you. I'm going to let you find EF on your own. So to find FG, we're going to take that 4x plus 1, but instead of an x, guess we're going to put in for x? 6. So that's going to be 24 plus 1, which is 25. So FG, the length of segment FG, is 25. Now I'm going to leave it to you to figure out what EF is. You got to figure out what EF is. Okay, moving on. Definition of congruent segments. We basically say that two segments are congruent if they have the same length. So let's look at segment AB's length. What is the length of segment AB? It's 10. What is the length of segment CD? Well, it turns out it's 10. Well, do they have the same length? Yes. Well, therefore, they are congruent. Now we write it this way. We say that AB is congruent to CD. Now, let me make sure this symbol right here means congruent. Okay? So congruent means they have the same length. So this symbol, I'll write it up here too. It's an equal sign with a tilde on the top. That means congruent. So we would say segment AB is congruent to segment CD because AB's length is equal to CD's length. All right, so now example 3 asks us, is segment AC congruent to segment BD? Okay, so let's do AC first. Let's see if we can figure out what AC is. So AC, according to our ruler postulate, is going to be, in the distance formula, is going to be A minus C. Okay, well, what's A? Well, A is negative 2. What's C? C is, I think that's a 5. So I think that's going to be 7, right? So the distance between those two guys is 7. Now let's go ahead and figure out the next guy, which is BD. Now look, I'm not writing the segment symbol on the top there because I'm actually finding the measure of it, the distance. Okay, so here we're going to do B minus D. Oops, vertical bar, absolute value. Let's see here. B looks like it's at 3, and D is at 10. So that's going to be the absolute value of negative 7, which is 7 again. So I would say, therefore, this 3 little dots like this, that means therefore, I'm going to say that AC with a segment symbol is congruent to B. And our last definition for this lesson is midpoint. Again, I know that you're probably familiar with a lot of these things. We say that M is the midpoint of segment AB if it divides it into 2 congruent segments. Now, we saw in the last slide that congruent segments are the segments with the same length, like let's say 5 centimeters and 5 centimeters. Another way we show congruence without knowing the actual length is we'll put little tick marks like this. So we would say that segment or length of segment AM is equal to the length of segment MB, which is another way of saying that segment AM is congruent to segment MB, and therefore these are congruent segments. Spell. Congruent segments, okay? Which means that M is the midpoint, okay? M is the midpoint. So M is the midpoint, the middle point, if those two guys are the same. So last question. Q is the midpoint. So they're telling us it's the midpoint. So what are PQ, QR, and PR? Well, if Q is a midpoint, what's that tell us? Well, that tells us that these two segments are congruent. And if these two segments are congruent, then they have the same length. Well, what is the length of segment PQ? Well, it's 6x minus 7. What is the length of QR? Well, it's 5x plus 1. So now we've got to solve this two-step equation. So first thing I'm going to do is I'm going to minus 5x on both sides, minus 5x on both sides. And that's going to give me, I'm going to go ahead and go over here. That's going to give me x minus 7 equals 1. So now I'm going to plus 7 on both sides. And that's going to give me x is equal to 8. Now I know what x is. X is 8. Now I got to figure out what these lengths are. So let's start with PQ. Well, what's PQ? Well, PQ is 6x minus 7. But what's x? Well, it's 8. So I got to do 6 times 8 minus 7. So I think that's 48 minus 7, which is, I think, 41. What about QR? QR is 5x plus 1. Well, x is 8 here, so I got to do 8 times 5 plus 1, which is 41, which should be no surprise, right? Because we already said that this was a midpoint. Q is a midpoint, then those two had to be the same. So now what would PR have to be then? What's the length of PR? I think I'm going to stop there. All right, that's section 1-3. Have a good day.